Welcome everybody. Today we are going to solve all easy SQL Hackerrank problems. So let's start. Revising the select query 1. Query all columns for all American cities in the city table with populations larger than 100,000. The country code for America is USA. Okay, we just have one table, city, and the output that we want is all columns. For all American cities in the city table. And we have two conditions. One condition, population is bigger than 100,000. Another condition, country code is like USA. So let's change to MS SQL. Select, so what we want, all columns. So we want the star from city, condition, where, what's the condition? Population bigger than 100, 1 to 3,000. And second condition, country code is like USA. Semicolon, and let's run it. And we got it. Congratulations. First one is done. Next one, revising the select query 2. Query the name field for all American cities in the city table with populations larger than 120,000. Okay, we don't want all columns now. We want the name. All American cities in the city tables with population larger than 100,000. Okay, condition is bigger than 120,000. The country code for America is USA. That stays the same. Okay. MS SQL. Select, not star, but name from city is called the table. Where condition population bigger than 120, 1 to 3,000. And second condition, country code like USA. Semicolon in the end. Let's run it. And we got it. Next one. Select all. Query all columns attributes for every row in the city table. The city table is described as follows. Okay, we just need all the rows. Got it. So all the rows we get with the asterisk or with the star. Select star from city. We need the city table and the semicolon and run it. No conditions. And we got it. Great. And the next one, select by ID. Query all columns for a city in city with the ID 1661. So we all columns means asterisk. Select star or asterisk from city where we have one condition, ID equals, what was it? 1661. 1661. And let's run it. Yes, we also got that. Congratulations. Japanese cities attributes. Query all attributes of every Japanese city in the city table. The country code for Japan is JPN. So all attributes means the asterisk from city is our table, where condition country code like JPN. Semicolon. Let's run it. And we got it. Next one. Japanese cities names. Query the names of all the Japanese cities in the city table. The country code for Japan is JPN. So we need the names now. Okay, output is names. Select, the column is called name. So we select name from table is city, condition where, country code, like JPN, and semicolon. Let's run it. And we got it. Next one. Query a list of city and state from the station table. The station table is described as follows. Okay, select, what do we need? We need city and state. The column city and state. City, state from station table. Okay, in the semicolon. Let's run it. And we got it. How many we have? 499. Okay, interesting. Next one, weather observation station 3. Query a list of city names from station for cities that have an even ID number. Print the results in any order, but exclude duplicates from the answer. The station table is described as follows. Okay, that's interesting. We want an output. Query a list of city names from the station table. Okay, so city names is in the column city, I'm guessing. So we need the output city. And we have two conditions actually. Condition, even ID number. First one is even ID number. And the second one is exclude duplicate values. Great. Okay, the even ID number. If you want to get an even ID, so what do we have to do with an even ID number? Let's take the English Google. We can actually do a modular mod in SQL. Let's look this one up. Okay, the mod is giving me select mod 18.4. That is MySQL, but we are with MS SQL. So mod MS SQL. You can see down, we always use MS SQL Server. So modulo MS SQL, this is what we need. We have dividend percent divisor. Okay, what the modular is doing, you can divide two numbers and then it gives you the rest of the number. And if we divide by 2 and we say that the rest should be 0, then we always get even IDs. Query a list of city names from station for cities that have an even ID number. Print the results in any order. Okay, select city. We want the city names from station. So let's just take the city names from station as the first run. Okay, now we have this city names, and now we want also the ID. Let's just see the ID. We don't actually want the ID in the end, but just to test it, we also give out the ID number now. Now we have the ID number. So we have even ones with 794 and also uneven 603. So let's try the modular statement here. From station, where, what did we look up? How did it look like? Dividend percent divisor. Okay, the dividend I think should be the ID column and the divisor should be the 2. And if they equal 0, then we don't have any rest is in this number. For example, 794 divided by 2 has no rest, has no remainder, and we get the remainder 0. Here 603, we get the remainder if we divide it by 2, 1. So we actually don't have it here. So now we should have all the even numbers. Let's see if that is correct. Yep, that looks pretty good. So we all have even numbers here. And we have another condition that we should exclude duplicates. And duplicate values you can always exclude with a distinct. So let's say distinct from city, from station, where ID %2 equals 0. Let's run this code. And we got it again. Okay, next one. Weather observation station 4. Find the difference between the total number of city entries in the table and the number of distinct city entries in the table. The station table is described as follows. Okay, so output, we need total number of city entries. So we can make count from city. And the other output we need is the number of distinct city entries. So we make distinct city. So let's just select the count from the city. The total number of city entries we have here. Let's just get this one first. Okay, count from city from station. How many city entries we have? Okay, so we have 499 city entries. And let's also get this distinct value. So then we make count from city, but we actually need the distinct city. So we count distinct from city. Let's run this one again. So now we have 499 and 486. Okay, and now we should just subtract these two numbers and we should have the solution. Okay. So let's put a minus, count from city, minus count from distinct city. And let's run the code. $13, we have it right. Okay, next one. Weather observation station 5. Query the two cities and station with the shortest and longest city name. Output. Shortest, longest city name. As well as their respective lengths. Plus lengths of city names. If there is more than one smallest or largest city, choose the one that comes first when ordered alphabetically. Okay. The station table is described as follows. For example, city has 4 entries: DEF, ABC, PQRS, and WXY. And we get out ABC 3 with a length of 3, PQRS with a length of 4. ABC because it's alphabetically in the first one, because it's A, and PQRS because it's the longest and there's no competition. No other has 4, so it's PQRS. Okay. Let's go to MS SQL. Let's select. So what do we do first? Let's select city and length from city. From from station table. Let's just look at this for a while. From station. Okay, so now we have the city names and we have the lengths. So how do we get the longest and the shortest? So we also have here a note. You can write two separate queries to get the desired output. It need not be a single query. Okay. So let's try first with, let's say, the shortest city names. So they are not ordered in any alphabetic form. So let's order them. Order by, let's say, city. But then we have to group by city also. Yes, group by city. Because we have an aggregate here, len from city, and then we always have to write a group by. Is len from city actually an aggregate? No, actually it's not, right? Okay, probably not necessary. So we have here the city and the length from the city. That looks good. Order by city. Should we order it by city? No, it's better to order it by the length of the city. So then we get the minimum on top. Order it by length from city. So that we get the shortest length of city on top. Because then we can just give out one column, only the top column, and then we should have the minimum. Yeah, right. So we have 3 with Amo, Lee, and Roy with 3 lengths. So now we just want Amo 3. This is already the first part of the solution. So let's just select top one line. Run the code. Okay, great. We just have Amo 3 here. So Amo 3, this is already the first part here, like ABC 3. And now we also need the longest, PQRS 4. And for that, we only have to run this code again. Let's make a semicolon here. And let's choose this code and put it again, because Node says you can write 2 separate queries to get the desired output. So let's write the second query. And let's order the length from the city, not ascending, but descending, so that we have the biggest one on top. And let's run the code again. And there we go. We have the marine on San Croix with 21 letters. And we got the solution. Okay, so the next one. Weather observation station 6. Query the list of city names starting with vowels, i.e. A, E, I, O, or U from station. Your result cannot contain duplicates. Okay, query the list of city names. So output should be the column city. That is our output. We have some condition. Condition. First one is start with A, E, I, O, or U. That's the first condition. And the second, no duplicates. No duplicates we make with distinct. So let's go to MS SQL. Let's select, we need the city column from the table name. The table name is station. From station, so let's just give the cities out and run this one. Now we have the cities, 499 cities. Okay, great. Now the first condition, where city, like, and now we start with an A. A percent. Percent means anything can come after that, but it has to start with an A. Or city like E%, or city like I%, or city like O%, or city like U%. So let's see if this gives us just the cities that start with these letters. Oh, we got it. All right. And we shouldn't get duplicates also, but apparently there were no duplicates because I didn't put distinct and I still got the right solution. Okay, so actually you should put it like distinct city to make it 100% correct, but anyway, we got the right solution. Okay, so next case. Weather observation station 7. Query the list of city names ending with vowels A, E, I, O, U from station. Your result cannot contain duplicates. Okay, MS SQL Server. Select city from station where city like, now it can start with anything, but it should end with A, or city like start with anything and end with E, and then A, E, I, O, and U. This is a condition. It should be a distinct from city because it should not have duplicates. So let's run this code. And we got it right. Perfect. Next one. Weather observation station 8. Query the list of city names from station which have vowels I, A, E, I, O, U as both their first and last characters. Your result cannot contain duplicates. All right, first and last characters. So let's select the city names, and we need the distinct city names because it should not have duplicates. From station where, so the vowels should be the first and last characters. Okay, where city like first character A, E, I, O, U. So we can make like A, which have vowels as both their first and last characters. Your result cannot contain duplicates. How do we write this one? So the first character is an A, percent A. So we have A, E, I, O, U, that should be first and last characters should be vowels. So let's query the city names like this. Select distinct from city from station. Let's look at the cities. So we have Acme, Edison. So Edison has an N here. Agency. Aguanga. How can we filter this out efficiently? So we can say from station where city like a percent and city like percent A. But that's not a very efficient approach. Oh no, wait, let's see something else. Where city in a percent E percent. So you write E in if you want to ask for multiple values. So city should be in and either a percent, E percent, I percent, O percent, or U percent. So it should start with vowels. And city in, and now it should also end with vowels. So that's the second condition. City is in percent A, percent E, percent, oops, percent I, percent O, and percent U. So now we're starting with a vowel and we're ending with a vowel. So let's see if this is the right one. No response. But I think this is about the right solution. Maybe we have to write it differently. Where city in. Okay, let's write where city like a percent. Or city like O%, or city like no, A, E, A, E, I, then comes O, and then comes U. And we close the bracket. And so now comes the next one. Take this one and copy it. City like percent %A. Now we need the percent %A. Percent %E. Percent %I. %O, and %U. So now we have one condition. It should start with A, E, I, O, or U, and it should end with A, E, I, O, or U. And let's run this again. And we got it. Perfect. Next one. Weather observation station 9. Query the list of city names from station that do not start with vowels. Your result cannot contain duplicates. Okay, so if it should not start with vowels, we probably need not like. So select first distinct from city because we don't want duplicates. From station where your result cannot contain duplicates that do not start with vowels. Okay, where city not in. I think this in didn't work. Didn't used to work, right? Okay, we try it again. Where not in didn't start with vowels. Okay. A%, E%, I%, O%, and U%. So let's go. Nope, this is not working. Not like. Okay, so we have to write not like. And we write not like A% or A, E, I, O, U. So we have A, E, I, O, U. It should not start with vowels, right? So now we have the solution A, E, I, O, U. And it does not start with vowels. So let's run it. And we got the wrong answer again. Oh, it starts Acme. How is that possible? I wrote the or, so I have to write the N. It has to be hard. It should not start with A and with E and with I and with O and with U. So this is the right one. And we got it. Great. Next one. Weather observation station 10. Query the list of city names from stations that do not end with vowels. Your result cannot contain duplicates. Okay, so this is basically the same as before. Select city distinct from city because we don't want duplicates. From station where city not like, let's say, end with vowels we have, right? So we have %A and %E and %I, %O, %U, %I, O, U. So let's run it. And we got it. Great. So the next one. Query the list of city names from stations that either do not start with vowels or do not end with vowels. Your results cannot contain duplicates. Okay, so now we have to put it together again. Select distinct from city, from station, where city not like that do not start with vowels or do not end with vowels. So it shouldn't start with vowels or it shouldn't end with vowels. Okay. City not like starting with vowels a percent or and. So we need the hard one here. And city not like e% and city not like I% and city not like O% and city not like U%. So this is the first one. Or it should not end with vowels. So we have here or take this one again. Let's make it an A here in the end, an E in the end, an I in the end, an O in the end, and a U in the end. U, that's right. So let's run the code. And we have it. I'm sure there is a more efficient way to write it, but we got the solution. Weather observation station 11. So now comes 12. Query the list of city names from stations that do not start with vowels and do not end with vowels. Your results cannot contain duplicates. Didn't we just made this solution? I think we did. Select distinct from city, from station, where city not like. Do not start with vowels and do not end with vowels. Okay, so that's different. Before we had or here and now we have and here. Okay, so we have to write the whole thing again. That's city not like. There gotta be a better way to write this, or let's try to find this out, because this is quite annoying. MS SQL not like multiple values. Yeah, that's right. Okay, it seems like he had the same problem here. So let's see if we can find it. And they're probably also doing the Hackerrank problem here with the A. Or no, he has BZ actually. I don't know. But let's see in this. If you use SQLite Reg App support, and we are using MS SQL unfortunately. Not like and not like. Yeah, we also wrote it like this. Okay, don't find a really much faster way. Let's just write it like this again. City not like A% or no and. We need the and this one city not like E% and city not like I%, not like A% and city not like E% and city not like I% and city not like O%. And now we need the U, so it doesn't start with vowels, and it should also not end with vowels. So now we have this one. It doesn't start with vowels. And should end with vowels. Let's take this one again. Don't make %, but make %A, so it doesn't end with vowels. %E, %I, %O, and %U. And let's run this again. Let's see. Yes, we got the right. And we have 299. Okay, interesting. So now comes higher than 75 marks. Query the name of any students who scored higher than 75 marks. Okay, so we need an output. We need a name from the students table, name. The students table is described as follows. Okay, so we just have one table. Good. And we already have a condition given. Condition marks bigger than 75. Who scored higher than 75 marks. Order your output. Okay. Order your output by the last 3 characters of each name. Okay. Order by last 3 characters. Interesting. Bobby, Robbie, etc. If 2 or more students both have the same ending name in the same last 3 characters, secondary sort them by ascending ID. Order by last 3 characters and then ascending ID. Okay. The most difficult is probably the ordering. So let's see. Select what do we want? Name from the students. From which table? From students table. Is here students. Condition is where marks equal bigger than 75. That's what we want. Yeah, right. So let's also write here the marks behind it, so we know we get the right outputs. And we have Samantha, Julia, Brittany, Kristen, and all with the scores over 75. Okay, so this is right until now. That's good. We don't need the marks anymore. And now we want to order it. So we need to order it by, so we have to order it by the name. Order by name, just to see this one. Okay, now we have the names. We ordered it by the names from A to V. And now we need the last 3 characters. So we can actually use a function called write, I think, here. So write gives me an output of the right side from this word. And how much letters it will give me out? It will give me out the letters that I give the number. So if I say 3, it gives me out 3 letters. So we can see it, for example, let's not make it with the order by for now. Let's comment this one out and let's see this one. Write from name, and we give out 3 letters. So to show you guys what the write function is doing. So now we get Thar from Samantha. That used to be Samantha. Let's see this also above there. Name and then the last three characters of the name. So we have the Samantha that gives out Thar, Julia gives out liar, Brittany gives out nay, and so on. So this is actually what we need in the ordering, because we want to order by the last three characters. Order by right from name, three characters. And the secondary order we can put behind it. And that should be by an ID ascending, ASC. Okay, and we will actually just want the name, not the right name 3. So let's try this one again. And we got it. Great. Then the next one. Employee names. Write a query that prints a list of employee names, i.e. the name attribute, from the employee table in alphabetical order. Okay. That seems easy enough. So we want to output the name in alphabetical order. Okay, order by name, basically. Input format, the employee table containing this and this. That is all. That is already the task. Okay, so that looks good. Yes. Okay, so let's go to MS SQL. Select. So we want the name, as we can see on the example output here. We want the names, the column name, from which table? From table is called employee. Okay, employee. We want to order it also by the name. Order it by the name. Let's give this one out. Semicolon. Run it. And we got it. Great. How many do we have? 100. Okay. Next one. Employee salaries. Write a query that prints a list of employee names, i.e. the name attribute. Okay, output is the name. For employees and employee having a salary greater than $2,000 per month. Okay. Condition is salary bigger than 2,000. The salary is an integer. Okay, so we can just write it like that. Salary is bigger than 2,000 per month who have been employees for less than 10 months. Okay, so we have more conditions. Having a salary greater than $2,000, and we have the second condition. So this is the first one. And second condition is employed less than 10 months, I think it was, right? Yes. Sort will result by ascending employee ID. Okay. So that is the third condition actually. Order by ID ascending. Okay, let's go with MS SQL again and select the name we want from employee, right? From the employee table. Okay, from employee and semicolon. Let's get the names at first. Now we got the names. Great. Now we got the names. And we have a condition. Where? What's the condition? Where salary greater than 2,000. Okay. Salary, do we have a column salary? Yes, salary. So salary greater than 2,000. Give also the name and the salary, just so we can check that it's working. Let's run the code. And we got we got everything over 2000. Okay, that's good. That's good, that's good. And we have another condition. And the employee should be less than 10 months. Okay, now we have the months, how long he's staying. So the column months should be actually less than 10. Let's run it again. Okay, now we got a little bit less. We don't really know how much months they were really staying. So let's put the months also out just to check. And they are all less than 10 months. Okay, less than 10 is the third number here. That's good. And let's also put the ID out and order it by ID ascending. That was the last condition that we still need. Let's put this all in one line so it looks a bit nicer and run it. Invalid column name ID. Huh, okay, how's it called? It's called employee ID. Okay, employee ID. Employee ID. Let's run it again. Invalid column name ID. I put it here again. Okay, employee ID. Wrong answer. Okay, so that looks good. It is ordered by the employee ID, and probably that prints a list of employee names. So we just have to print the list from employees. Okay, so we have to take all the other columns away now, and that should work now. Let's see. And we got it. Perfect. Type of triangle. Write a query identifying the type of each record in the triangles table using its three side lengths. Output one of the following statements for each record in the table. Equilateral. It's a triangle with three sides of equal length. Isosceles. It's a triangle with two sides of equal length. Scalene. It's a triangle with three sides of different lengths. Not a triangle. The given values of A, B, and C don't form a triangle. The triangles table is described as follows. A, B, C, all integers. Each row in the table denotes the length of each of a triangle's three sides. Okay. Sample input A, B, C 2020-23 is an isosceles. Why? What's an isosceles? It's a triangle with two sides of equal length. Okay. Equilateral, it's with three sides of equal length. Okay, that looks like a case statement, I would say. So what do we have to output? Write a query identifying the type of each record in the triangles table using its three side lengths. Output one of the following statements for each record in the table. Okay. Output statement. Okay. Let's switch to MS SQL. And let's select. So what do we want? Select star from this table just to look at it. From, how's the table called? Triangles. Triangles. So 10, 10, 10. Okay. Then let's make a statement here. Case. Where do you do the case statement again? Let's look it up. Case statement, case SQL, case MS SQL. Exactly. Case statement. So case when A equals B equals C, then let's say equilateral. We should have then, right? If everything is the same, it's equilateral. And let's make another one. So the case statement is checking when A equals B equals C, then equilateral. Else, what should it do else? Else, 0. Just write 0, just for now. Let's see if this was working. Incorrect syntax. I think we need the double equals, yeah? If you write it like that. A equals B equals C, I think so. No, it's still the incorrect syntax. Near equals. Okay. Maybe we can only compare two of them. If A equals B and B equals C. So now we have basically the same thing, but maybe we can just compare two. No, it's still incorrect syntax. Interesting. Case when, then the expression, then the result expression. We have to write an end at the end, huh? Okay. Well, maybe because we didn't write this end, so we can see here in the syntax, an end in the end. End in the end, yeah, makes sense. So let's go. No, it's still wrong. Line 5, incorrect syntax near equals. Okay, maybe not the double equals. Let's make here the parentheses, and let's make just a normal equal. A equals B and B equals C. The varchar value equilateral to data type int. Okay. Then equilateral, can we not print it just like that? Or maybe print equilateral, then print. Okay. Then 1. Let's say 1. Okay, so this is working. Okay, but I want to give out a string. How can I do that? Convert. No, convert doesn't make any sense. So on the case MS SQL and then print. And print. Name process case when then rejected. When 7 then rejected. Okay. Case process code. Process code as status. Oh, maybe I have to give it another integer. Just missing the end of the case when clause and a comma, and not sure you need quotes around process code. Then rejected, else approves. When A equals B and B equals C, then can I not give out just equilateral? Equilateral. Else, maybe else. Okay, maybe because this was a number, not equilateral. Like this. Okay, this is working. Perfect, okay. It was because I wrote a number here and else, and I had here a string. Okay, so now we can go with it. When A equals B and B equals C, then we have all the sides correct, and then we can print equilateral. Yes, that's right. Okay, so that looks good. So then let's make the next one. When, what is the next case? We have equilateral here. Isosceles. It's a triangle with two sides of equal length. Two sides of equal length, okay. When A equals B or B equals C, then we have two sides of equal length, and then we print isosceles. Then isosceles. Let's run this one. Isosceles, yes, that's the right one. Yes, that's also looks good. Okay, then the next one. It's a triangle with three sides of different lengths. Okay, that's the next case. When A unequal B and B unequal C, then of course A is also unequal C, then we have here scaling. Scaling. Okay. Scaling. Right. Scaling, yes, that's true. Scaling, scaling, scaling. It's a triangle with three sides of different lengths. Not a triangle. The given values of A, B, and C don't form a triangle. How can I know if it forms a triangle or not? Three side lengths. Not a triangle. Triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the measure of the third side. Okay. So it's a scalene if the sum of two sides must be greater than the measure of the third side. Okay. Okay, so we have another condition here. And A plus B bigger C and B plus C bigger A. So each two sides and A plus C has also B bigger than B, and A plus C bigger than bigger, not equal. So that means it is a triangle. If they are bigger, then you can also call it scalene. Else I will call it a triangle, not a triangle. Okay, let's run it and see what is telling us. Equilateral, that looks good. Scalene, that looks good. And on the triangle here, we have not a triangle. Okay, perfect. So that looks pretty good. Let's run it without this asterisk so we can get the right answer. Run the code. Nope, it's not the right answer. Okay, let's read some text here. Values in tuple 2023 form an isosceles because A equals B. Okay. Values in tuple 2020 form an equilibrium. Yes, okay. We have this one also right. Values in tuple 2021-22 form a scalene because A unequals B unequals C. Yes. And values in it cannot form a triangle because a combined value of sides A and B is not larger than that of side C. Okay. Then where do we go wrong here? Maybe we have to order it. Write a query identifying the type of each record of the triangles using its three side lengths. Output one of the following statements for each record in the table. Okay, we did that. We have 15 records, right? Let's see this again. Run the code. We have equilateral, yeah, that looks good. Scalene, 30-30 is bigger than 32. Yes, 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 that looks also good. Oh no, scalene, why is this scalene? It should be an isosceles. Okay, so this one is wrong. A equals B or B equals C or A equals C. Of course, this can also be true, and then it's an isosceles. So let's run this one again. Yeah, now it looks better. Now it looks better. Let's try it. Wrong answer. Wrong answer again. Okay, let's check again. Star. Equilateral isosceles because two sides are the same length. Equilateral. It's also true. Isosceles, yes. Equilateral, scalene, 2021, 22, yes. 2020, 40, isosceles. No, this is not an isosceles because the combined sides here are not greater than 40, they're equal 40. Okay, so we actually have to put a condition in isosceles also. The condition that the combined sides cannot be bigger than the third one. And that is this condition a plus b, b plus c, and a plus c. So this condition, we also have to put it in isosceles. Let's copy this one and put it here. And run it again. Still not right. Let's see, equilateral, equilateral, isosceles, equilateral, isosceles, equilateral, scalene is also right. Still says isosceles here. A plus b is bigger than c. A plus b is greater than c. How is a plus b greater than c here? Because we put an or here, huh? Okay, so we have to put this or in another brackets here. Or, and now it should look right. Let's go. And we still have the wrong answer, huh? Not a triangle. Yeah, it is not a triangle, right? Because two sides must be greater than the third side, yes. So here we have not a triangle, which I think is correct. Scalene, scalene. It's also scalene. Not a triangle. Not a triangle. Scalene. Equilateral. No, because we have to put the star out here, of course. Now we can run it again. Just need this once. And we got it. Okay, so next one. Revising aggregations. The count function. Query a count of the number. Let's put this one away. Query a count of the number of cities in city having a population larger than 100. 100,000 or 100? I think it means 100,000 with a comma, right? Query a count of the number of cities in city having a population larger than 100,000. Okay, select count from city where population bigger than 100,000. See? Nope. Invalid color name city. Okay, count from name. Oh, it's name, not city. Okay. And we got it. 6. Revising aggregations, the sum function. Query the total populations of all cities in city where district is California. Okay. Select total population of all cities. So population, total population of all cities. And it's called the sum function. So better use the sum function. Sum from population from table city where district is California. Okay, where district like California. See? And we got it. Revising aggregations, averages. Query the average population of all cities in city where district is California. So select average from population from table is called city where district like California. California. Let's run it. Nope. Invalid coordinate name district. No, it didn't mean district. I mean district. Let's go. Yes, next one. Average population. Query the average population for all cities in city rounded down to the nearest integer. Select average from population from city Let's run this code. It automatically rounds to the nearest integer. Perfect. Now we already have this. Query the sum of the populations for all Japanese cities in city. The country code for Japan is JPN. Okay. Select sum from population from city where country code like JPN. Let's run it. And we got it. Population density difference. Query the difference between the maximum and minimum populations in city. The city table is described as follows. So let's select max. Difference between maximum and minimum. Okay, max population and min from population from city. Okay, and now we need the difference. So let's make the minus and let's run it again. And we got it. Blunder. Samantha was tasked with calculating the average monthly salaries for all employees in the employees table, but did not realize her keyboard's zero key was broken until after completing the calculation. She wants your help finding the difference between her miscalculation, using salaries with any zeros removed, and the actual average salary. Write a query calculating the amount of error, actual minus miscalculated average monthly salaries. Okay, so what do we need? The average monthly salary for all employees in the employees table, but didn't realize her keyboard's zero key was broken until after completing the calculation. She wants your help finding the difference between her miscalculation, using salaries with any zeros removed, in the actual average salary. Write a query calculating the amount of error and round it up to the next integer. To the next integer, okay. So we need the actual salary minus miscalculated salary. Round to nearest integer. The employees table is described as follows: ID, name, salary. 2061 we have here, okay. Table below shows the salaries without zeros as they were entered by Samantha. Okay. Let's first get a look at the actual table. Select star from, what's the table called? Employees. From employees. Actual table. We have 20 entries, okay. This is the actual table. Miscalculated table. Miscalculated table. And how do we get then the other table now? Okay, so we have ID, name, salary. So we have the ID, we have the name, and we have the salary. What's the salary for a data type? Integer. Okay. How can we remove the zeros now? Maybe with replace. Replace salary 0 with nothing. Let's see if this one works. The replace function. And yep, this is working. So this is the miscalculated table without the zeros. And now what do we want to do? Salary is measured in dollars per month and its value is smaller than 10 to 5. Okay. So we want the average monthly salaries for all employees in the employees table. Okay, let's make the actual average salaries from the actual table. Actual table. Make average salary. $4,046. That looks about right. And now we want the miscalculated one. Minus. And the one where we replace the zero. Average from replace salary 0 with nothing. And this one. Nope, that's not right. Operand data type varchar is invalid for average operator. Okay, so you have it in varchar now. This replace is now a varchar data type. Even though we had before the salary, we had it in integer. Oh, okay, he converted automatically by using the replace function. He converted this data type, salary, from an integer into a varchar. So we have to convert it back. We can use cast actually for this. I think, let's see the syntax from cast, MS SQL cast. Cast function, select cast from, okay, cast from the salary, oh no, from the replace. Cast from replace salary 0 with nothing, and I write it as int. We actually want the integer again. So let's see if this is working. Incorrect syntax near semicolon. Okay, 1, 2, 3 brackets open, 1, 2 are closed. Okay, that's not good. Replace salary 0 with nothing. Cast from replace salary with nothing as int. And now the average from all of them. Now we have to close one more. 2,252. But it's the wrong answer. Was tasked with calculating the average monthly salaries for all employees in the employees table, but didn't realize her keyboards. She wants your help finding the difference between her miscalculation and the actual average salary. Write a query calculating the amount of error and round it up to the next integer. Actual minus miscalculated. Round, okay. Round MS SQL. Round from this one. The right one here. Maybe if we round both of them. Round to the what? Nearest integer. To the next integer. Okay. Round it up. Okay. Round it up to the next integer. How can we round it up? Round up MS SQL. Round. Round. How can we round it up? Ceiling. Ceiling. Maybe this is the one. Ceiling from this one. Okay, and the function returns the smallest integer greater than or equal to the specified numeric expression. Okay, I think this could work. So here we get the wrong. Ceiling looks pretty much like the one that we need now. Ceiling from average salary. Close it. And wrong answer. So maybe we put the ceiling here. We also give him a ceiling, and then we give it out. Still the wrong answer. Why is this not working here? 2252. Oh, let's make the +1. Okay, so this is the right one. The 2253. But where do I have to actually round it up? Where can I round it up here? Average from salary. Ceiling from maybe before I make the average. Ceiling from average from salary. Ceiling from the cast. This is not working. So I have to put the ceiling here. Ceiling from cast from replace salary. As int and then close it here. Nope. Okay, so this is the solution. We have to round it up to the next integer, so we just make a +1. And there we have it. Top earners. We define an employee total earning to be their monthly salary times months worked, and the maximum output, and the maximum total earnings to be the maximum total earnings for any employee in the employee table. Write a query to find the maximum total earnings for all employees as well as the total number of employees who have maximum total earnings. Maximum total earnings. Then print these values as two space separated integers. Okay. Two spaces. Total number of employees who have maximum total earnings. Total number of employees with maximum total earnings. So what's the sample output? Two numbers, okay. To find the maximum total earnings for all employees as well as the total number of employees who have maximum total earnings. Okay, let's select first the table. To look at it, select star from employee. $106. And now the maximum. We define the employee's total earning to be their monthly salary times months worked. The only employee with earnings equals 69,952 is Kimberly. Okay, earnings. Oh, we have the earnings already here, huh? Earning salary. She put this one next to it. Okay. So months times salary. So we have here months times salary. Maximum total earnings. And now we want the count. Here is 1. The count from max from months times salary. Okay. Maybe like this. Try this one out. Okay. So max from month salary. 108,064. And how many do have this salary? How can I get this number? How many have this? Oh, we have to count. We have to count the employees which have this salary. Okay. So we have this number. And we write, one is a case when months times salary equals max from month times salary. Okay, now let's forget about the max a little bit and try a different approach. So let's take month times salary. Good. Now we have the nonce times salaries. The maximum, how did they call it? Maximum internal earnings. And now we want to order it. Order it by month times salary. Okay, that's good, that's good. And now we needed to order it descendingly. Perfect. So now we have 7 rows with 108,064. So how do we get this count out? Here we have 1 because we have 1. Now we have 7 here. So one way to do that, I think, is the rank. But let me look this up. Let us look this up again. So rank MS SQL. So rank over partition by. So they are row number and rank. Rank over partition by employee ID. No, partition by months times salary, right? Yeah, partition by months times salary. Let's see how this one is working. Incorrect syntax near partition. Okay, so obviously this is not right. So how do we write this correctly? Rank over order by rate descending. Okay. So we write rank over. So I'm reading this one here now. Rank over. So we don't write partition by, but we write order by. Order by months times salary descending as rank. I don't know. We don't see the column names anyway. So let's see what comes out. Okay, so we have the rank number 1 here. We don't really want this. We want all of this to be 8. Maybe we have to use the row number here. Row number. Maybe that was the right one and not the rank. row number is row number really just gives me continuous numbers, but I can partition in the row number. I can partition in the row number. Partition by months row number over, and then comes the partition by. So row number over order by. Okay, but we also want one with partition here. Partition by and then order by. Okay. So we write row number over partition by called months times salary. Months times salary descending and order by. Months times salary descending. Now let's see what we get out here. Incorrect syntax. Partition by. Maybe we cannot write descending here. Partition by month and salary. No problem. Just write partition by. And descending we already have no order by. We don't need 2 times the descending. Okay, that looks good. So we have here 7. Seven. Now how do we get this one out now? The 7th line. Maybe this is still the rank. Let's try the rank again. Like this. No, it's all rank 1. It's all rank 1, huh? Okay. Row number. What I actually want is to have the 7 on top. So you can just give out the first line and then we would have the solution. 108,064 and then the 7. That's what we have to give out. How can we get this one out? Maybe the max from row number? Max from row number. No, it is not working. This is not working. So we need month salary, then count from months times salary. And then we have nothing, because we have to group by months times salary. Let's see what we have now. So here we have what we are looking for. Perfect. The first line, 108,064, we actually exist 7 times. So let's select just the top line here, the top 1 lines, and then we have the answer. And there we go. Off to the next one. Weather observation station 2. Query the following 2 values from the station table. The sum of all values in let n rounded to a scale of 2 decimal places. The sum of all values in long W rounded to a scale of 2 decimal places. So output, we need sum from let n and sum from long W. Okay, let's first get this ones. Here's a square. Select sum from let n and sum from long W. From station, I think was the name, right? Yes. And long V from station. So let's see. Incorrect syntax. What is incorrect here? Sum from let n and long W. A form. No, we don't want form, we want from. Let's go. Okay, so we have a lot of decimals here. So let's go to, what can we use? We could use round, I think. What's the syntax again for round? So round MS SQL. Oops, oopsie, round here. Round the length function. Okay. So probably if I just write 2, here he writes -2. So no, I just want 2. Round from this one. I want 2 decimal places. Round from the sum. And also 2 decimal places. Okay, so now we actually have the right outcome. But it's actually showing all the zeros behind, and we don't want this to show. So we could make maybe a convert. A convert could solve the problem. Convert from sum as how do you write the convert again? Convert SQL convert. Convert. Give me some examples. Okay, you're just writing so much. Cast as char1. Okay. Cast as int. I need a convert example. Convert. I think I have to write it here decimal. 10, 2 with 2 decimal pieces. And write it like this. Let's see if this one is working. Yes, now we have the 2 decimal places. So, okay. So we don't write the round here with a 2, but we write it with a convert from the sum long V. And what do we want to convert it into? In decimal from 10 digits and 2 digits after the comma. So let's go. And there we have it. Great. Next one, weather observation station 13. Query the sum of northern latitude from station having values greater than 38.7880 and less than 137.2345. Truncate your answer to 4 decimal places. Okay, we can use the convert function here. So that's the query the sum of the northern latitudes from station having values greater than and less than. Okay, so sum of let n condition values between 38.7880 and 137.2345. So let's see. Select sum from let n from station where let n between 38.7880 and 137.2345. Let's see. Okay, we got one. We got a number. That's good. And we need 4 decimals. So let's make a convert to decimal. 10 digits in total and 4 digits after the comma. And we take sum from let n, close the bracket, and run the code. Yes, we got it. Weather observation station 14. Query the greatest value of the northern latitudes from station that is less than 137.2345. Truncate your answer to 4 decimal places. All right. So you want an output. Select. What do you want for an output? Let n. Okay. Let n from station. Select max because we need the greatest value. Max from let n from station where let n is smaller than 137.2345. And that looks good. And now we have to convert it. Convert the value into a decimal with 10 digits in total. And how many digits after the comma? 4. 4 digits after the comma. And this maximum from let in. Close it off and run the code. And we got it. Perfect. Query the western longitude for the largest northern longitude in station that is less than 137.2345. Okay, interesting. So we want to have select the western longitude, long V, from station where let in is smaller than 137.2345, and we want the maximum from long V. Maximum. Let's run this. $164, okay, and now we have to convert it to 4 decimal places. So convert decimal 10 digits, 4 after the comma, from max long V, long W, and nope, still not it. Okay. Let's see again. Query the western longitude. Yes. For the largest northern longitude in station that is less than 137. Where max from Latin. Max from Latin was that, huh? What's the problem? But we can actually not put an aggregate in the where clause. Then we have to put a having here. Okay, having, because it's already aggregated, we have to put it in a having. Let's see if this one's working. No response. Having max from Latin. Query the western longitude for the largest northern latitude. In station that is less than 137.2345. Round to 4 decimal places. But we are looking for the maximum let in that is less than 137.2345. Maybe I don't have to put the max long here. No, I just need the long. Query the western longitude, not with the max, just the western longitude for the largest northern latitude. Query the western longitude for the largest northern latitude in station. So what is the largest northern latitude in station that is less than this one. Okay, and then we make max from let n where let n is smaller than 137.3345. Okay, so this is the biggest northern latitude. Select let n, group by max, or group by let n, having max from let n smaller than 137.2345. Mm-hmm. Now he's giving everything out. Okay, but that's not too bad. And now I want the western longitude. Long W. Long W from station. Having maximum latent smaller than 137. I have to group by long W, of course. Group by long W. Okay, great. Now we have this ones. Now we convert it. Convert decimal 10 4 from long W. Western longitude. Okay, that's good, that's good. And now we need actually, what do we need? Query the western longitude for the largest northern latitude and station that is less than 137.2345. Order by let n, maybe. This is getting a bit complicated here. It's too complicated. Okay, again. Select western longitude. Okay, so we need the long largest northern latitude. Okay, let's just give out also the northern latitude from station. For the largest northern latitude and station that is less than 137.2345. Okay, longer western longitude, northern latitude from station. Group by longitude, northern latitude, having max from latitude 137.2345. Let's see this one. Okay, interesting. What do we need actually? Order by northern latitude. So, okay. And 126. The biggest query the western longitude for the largest northern latitude and station. Descending. So we have here the largest northern latitude on top. Perfect. Here we have the largest northern latitude on top. And we need the western longitude. This one we need now. Okay, so basically we just have to give out the first line here. Because we have the largest northern latitude on top, which we wanted. And we want to query the western longitude for that. So this number here. We just have to convert it to 4 decimal places. Okay, perfect. The western longitude number, yes. Okay, so let's take the first line out. Select top from 1. And we have here the convert from decimal 10 digits, 4 after the comma, and the long W. Let's run this one. And we got it. Congratulations. And the next one. Weather observation station 16. Query the smallest latitude from station that is greater than 38.778. Okay. Select min from let n from station where let n is bigger than 38.778. See if we get a result here. Yep, so let's cast this one to the 4 decimal places or convert it into a decimal with 10 digits and 4 after the comma. Put the comma and close the brackets and let's go. And congratulations. So the next one. Vary the western longitude where the smallest northern latitude in station is greater than 38.778. Okay, select from long W from station long W and let n from station group by long W let n having min from let n bigger than 38.778. And this one we have to order by let n sending. Perfect. So query the western longitude. So we have to get western longitude out, where the smallest northern latitude in station is greater than 38.778. Where the smallest northern latitude. Okay, so I actually have to get the smallest northern latitude. So let's make an ascending. Where the smallest northern latitude in station is greater than 38.778. So here we have the smallest northern latitude, yeah, the smallest that is greater than 38.778. 38.852. This is the smallest, and this is now on top, which is very good. So now we just have to get this long W, because here is the smallest northern latitude that is bigger than 38.778. And now we just need the first line. So the 70.1377. And we have to convert it to 4 decimal places. Convert decimal 10 digits, 4 digits after the comma, and the western longitude. Let's run this one. And we have to get, of course, just the first top line. One line. And there we got it. Off to the next one. Asian population. Given the city and country tables, query the sum of the populations of all cities where the continent is Asia. Okay. Select sum of population. From where do we take this population? From city. From city, we also have to join it. Left join with the other one. City and country table, city country code and country.code. Okay. Left join country on country.code equals city.country code. Where what do we want? Continent is Asia. Continent like Asia. Okay, run this. Ambiguous column name. Okay, so this column name has to come from city. City.sum population. Oh, that's right. Sum from city.population. This is how you write it. And we got it. Off to the next one. African cities. Given the city and country details, query the name of all cities where the continent is Africa. Okay, seems the same as Asia, just with Africa. Let's go. Select sum from city dot population. Do we want the population or query the names of all cities where the continent is Africa? Okay. City dot name. From city left join city dot code. No country left join country on country.code equals city.country code where continent like Africa. And what do we got? We got it. Yes, congratulations. Average population of each continent. Given the city and country tables, query the names of all the continents. Okay, output name and their respective average city populations, rounded down to the nearest integer. Okay, so we want the name and the average from population. Query the names of all the continents, country.continent, and their respected average city population, city.population. Okay, let's get the each continent first. So select names of all the continents, country.continent. Okay, select country.continent from country left join city on city dot country code equals country dot code. Let's run this one. Okay, so we have a lot of continents here. Country.continent. What do we say of population? City.population. Population. Do we get here? Okay, North America has no population here. Country.continent. City.name. Name and city.population. So we have to group by the continent actually. Yeah, group by the continent, that's a good idea. Group by continent. We need the country.continent and the average city populations. So average from city population. Incorrect syntax near the keyword left. Where do we have a keyword left? Line 6, left join. Group by continent. Ah, okay. Left join has to come before the group by, of course. Run this. Oh, we have nodes here. Query the names of all the continents and their respective average city populations, rounded down to the nearest integer. Rounded down. Okay, rounding down. How do you do that? Round down. Here's SQL. Floor it is down. Okay. Floor from we still have the null values here. So we actually have the floor here. And we still have the null values here inside, so we have to where city.population is not null. And now we have it. Draw the triangle. P from R represents a pattern drawn by Julia in R rows. The following pattern represents P from 5. Okay, so we have 5 stars, 4 stars, 3 stars, 2 stars, 1 stars. Write a query to print the pattern P.20. Let's start with 20 stars and goes down to 1 star. Okay, now we have the question actually. Question: how to print a star? How to print multiple rows that are changing values. Probably we have to do a loop here where we always count one down with a variable. So let's see the variables in MS SQL. SQL variable. So we have to declare maybe a variable at counter, counter. How to print a star? Print a star in SQL. Or maybe just print a letter. Write while. So we have a counter, variable SQL. Let's take this out. Declare my counter int. Oh yeah, we can do it like this. Declare it counter int. Set counter equals 0. Equals 20. Let's say 20 because we need 20 times. While counter bigger than 0, begin. And here we have the end. Okay, so we have here we have a loop. That's good. And in the end we say set counter gleich counter -1. In the beginning, in the meantime, we want to do something. So we have declared a variable counter, set the counter to 20 because we want to print the pattern p from 20. While counter equals bigger than 0, we begin and we set counter to counter -1, and now we want to print actually the stars. The star. How can we print the star now? Print from 1 star. Let's see what this gives. Okay, now we printed 20 times 1 star. Okay, so this was working. But how can we print less of it every time? So maybe if we can print this one in every row as often as we have the counter. For example, in the first row the counter is 20 and we have the star here. If we can print the star 20 times in the first row, then we would have the right pattern. We'd have 20 in the first row, 19 in the second row, 18 in the third row, and so on until the one in the last row. So how do we get that? Print ladder MSSQL n times. Replicate. Replicate. That could be a good function. Thank you, Google. That sounds good. That sounds good. That sounds like we could use it. Replicate 0, 4. So replicate is a string and an integer expression. Okay, that's good. So let's say replicate. Replicate. String is a star. And integer is get counter. And let's run this. Come on. Incorrect syntax near replicate. Okay. Replicate string integer. Maybe we have to put a print also around this. Print replicate counter. Yeah, that could work. That could work here. Yes, it looks good. It looks not so bad. But I think we have P from R represents a pattern drawn by Julia in R rows. The following pattern represents P from 5. Write a query to print the pattern P from 20. Okay, it looks like they have a small break between them. Anyway, so the pattern looks right until the end. But I think they have a break between them. A line. Or, yeah, like a space. One space. So maybe with a space, it's right. Yes, now we got it. Perfect. Congratulations. Okay, let's save this one. Because the next one is called Draw the Triangle 2. Probably it's similar to that. So let's save this one for the next code. Close this one. Draw the triangle 2. P from R represents a pattern drawn by Julia in R rows. The following pattern presents P from 5. Write a query to print the pattern P from 20. Okay, so now basically I just have to do it the other way around. Declare add counter int. So we had the counter 20, now we need the counter to 0. And now while counter is smaller than 20, and we plus 1, we put the counter plus 1, and now it should already work. Let's see. Nope, it's not working. Wrong answer. So the first one has no asterisks here. Okay. Maybe we have to set the counter on to 1. And the last one should be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, that's 1 too less. Then let's make this one smaller equals 20. And we set the counter to 1. And now let's go. Let's go, baby. Yes. Yes, we did it. Whew. So we have all easy problems solved on Hackerrank SQL. So see you in the next one.